Okay, I think it's time to get started. My name is Chou-han, and I'm principal engineer of BloomReach, and I've been working for this company. We're based in Mountain View for 4 years. It's my honor to be here today because this is actually the first public talk since we open sourced our job flow control system called Briefly. And I would like to walk you through, some of the challenges, some of the kind of cool ideas that we use, Python to drive a very complex data processing pipeline, particularly Mapreduce or Hadoop. So I would like to spend a few slides, just basically give you a little bit background of the challenges and the problem we're facing. I don't want to get too much about the product since this is not the main talk today, but just enough so that you know what the problems we're facing every day. And also, I try to make sure that each component of the Briefly job control system is independent. So even if you you don't end up using Briefly, you probably still can get some cool idea that you want to do with your data processing pipeline per se. So that's kind of the goal today. So let's jump in directly to some background. And Briefly is actually used throughout the whole company for all the stuff we're doing. And the mission for BloomReach is basically providing useful information as a platform for our customers. So we get a lot of data from pixels, get the traffic data, we crawl our customers' page, we get a feed. So the pipeline is doing a lot of things like parsing, indexing, get the analytics, calculate traffic, everything you can imagine. So just for example, the pipeline of my team, we're actually crawling 20 million pages a day, which generate about 500 gigabytes of data. And we have to parse them, and they're all unstructured data, and we have to index them as well. So imagine this pipeline needs to be executed every day. So the technology stack we use, of course, is Hadoop, and we don't have our physical servers. And for those who are not familiar with Amazon EMR, it's basically just some a Hadoop service. If you don't have your Hadoop cluster, you can just say, hey, give me 10 machines, 100 machines, or whatever, and then they created this cluster for you. And for storage, we use S3, Cassandra, and front end, and of course, the flow control, we use Python Briefly, and a little bit shell scripting. So this graph shows you the kind of the challenge we face, because we do have several products. As you can see, our instance hour for electric Mapreduce actually grows really fast, exponentially. So recently reached 700,000 hours. So this kind of translates to several thousand machines running every time, 24/7. And this is actually good news and bad news. Probably good news for Amazon because they get a lot of money, 300,000-400,000 per month, and it's just for EMR. And of course, bad news for us. So imagine that if you can actually make the Mapreduce pipeline or the cluster a little bit efficient, you actually save a lot of money. So here are the challenges. Of course, you have very complex, a lot of Mapreduce and local processing, maybe with scikit-learn. And they're all getting from different sources, like local files, remote file on S3, maybe some SQL server, just everywhere. And customers, may have different requests. So even if you have the same processing pipeline, you probably want to modify a little bit for each customer. As this actually created a lot of problem for us. And of course, the processing cost is just skyrocketing. It's crazy. And we're using one feature called spot instances. This is actually Amazon allows you to place a bid price to bid how much you want to pay for this particular type of instance. So we want to use this just basically reduce the cost throughout the whole company. And one of the biggest problems is that once you have a very complex Mapreduce data processing pipeline, it's actually very difficult to debug. Like imagine that you run a pipeline, you have to wait for an hour before your cluster gets started, and after an hour is finished, and then you just found a problem, you have to run it again. So basically, the complexity is the enemy of the whole data processing pipeline, and you really need to run in a different environment for testing, for example. So before we decided to build briefly, we actually compare like few existing systems, and we actually try to use them. Like for example, you can just write a makefile. And the problem for makefile is that if you have files on S3, it's really difficult to check the timestamp and then create a dependency, for example. But it works, to some extent. And we also tried cascading. Cascading is sort of like only for Hadoop. If you want to build anything in Hadoop, they can run locally. But the limitation is that everything is inside one cluster, which is not good for us because we have like hundreds of clusters at the same time. So what happens if you want to control more than one Hadoop cluster? Can you actually do that? And another sort of like more closed system from Spotify is called Luigi, and they do have some good stuff. But we really want to push to another level that would give a lot of support to Hadoop cluster particularly. So that's kind of the thing we're trying to do. So the goal for briefly is that we really, really want to create a very complex pipeline in a very concise language, in a way that I don't want to write a lot of boilerplate. I don't want to create a class, for various simple thing like just run a Hadoop. And I don't want to deal with operational issues because some cluster Amazon may tell you, oh, this cluster failed because the bootstrap had some problem. I don't want to deal with that. And I really want to make this pipeline robust, and then so you can test it locally, remotely, every environment, it just works. So this is actually the architecture for briefly. On top of it, we have sort of like meta programming. You can build your own pipeline, and then it goes to the execution planner, and then it actually executes the job flow in multiple threads. And it actually interacts with file storage, a Mapreduce driver, talk to Amazon through Boto library. So you don't have to deal with the API yourself. And everything should be really, really sort of like clean. And before we jump to this component, I just want to give you a really kind of a quick flash how briefly actually look like, so you don't get lost. And everything is open source. So the example I give you is actually on GitHub. If you Google Python briefly, that should be the first link, and you should find it easily. So if I just open those files, we will look at them in detail later. So don't worry too much about the syntax itself. So the briefly pipeline looks like this. You basically create an object like called pipeline, and then you define a bunch of functions. Like, hey, you have a pretty print function, you want to do something. You can have a dump, function you want to do something. You can actually have a shell process you want to do something with shell. And you can even have a Hadoop process. We'll look at that later. Then what you have to do is basically just chain them all together like this. Like we have pipeline 1, 2, 3. And then in the end, we just basically put everything together. Sorry, can you read the very last line? Can people sit behind to see this clearly? Okay. I'm not quite sure. Can you help? Yeah, okay. So the cool thing about it is that, if you just think this is like iterative programming, you're probably wrong. You can enable like multiple thread. So this 3 pipeline, they can actually run in parallel. So you don't actually even see, is it like in how many threads or like how many clusters, and how we can drive a Mapreduce cluster in a parallel fashion. So this actually works. Okay. So let's continue to the first component, which is the execution planner. And let's take back a little bit so to let you know what the intuition comes from. So people are really kind of familiar with this type of pipeline. I think everybody uses this in shell scripting. And you get some data, you sort a unique -c, and then this is actually called a histogram. You haven't tried I think people really love this type of thing in BloomReach because it's just quick. If you have several gigabytes of data, there's no problem. You can just get the quick analysis of how your data look like. So there are a few components. If you look at this, we have basically cat get your source, and then we have few process sort and unique. So this is kind of like the concept of pipeline. So what the shell script, the bash shell help you to do is basically it trains the input and output for you. And just so you know, there is actually a name for this type of syntax called Hardeman pipeline. If you wiki it, it's just use this pipe or operator to chain them together. So then the question is that can we actually use the very elegant syntax similarly in Python? And of course, you've already seen that the answer is yes. But we would probably need to twist it a little bit. So first, we have to change. Originally in shell scripting, you put parameter after space, and in Python, you want to call it in a way like a function. And of course, we want to change the input and output between two nodes. So like in this example, you want to put the output of this function to the next one. So that's kind of the trick you have to do. So how you can do that in Python in a way? Of course, if you actually return an object, some object, and then you overload this pipe or operator, then you can chain them, right? So that's kind of the first intuition. But then quickly we have another problem. Like this pipeline, we actually have two input. Input 1 goes to full process, and input 2 goes to bar process, and then we put them together. So in this case, we really, really want them to execute in parallel. So if you actually run this in Python like a function, then this result 1 needs to be evaluated first, right? And then before you go to the next line, it's already evaluated. So this method's probably not going to work as what we want. So this is not powerful enough, so we don't like it. So of course, the real solution is that we need to build some sort of graph. Like this graph basically represents our data processing pipeline. So every single node would be some sort of process that you can execute. And then we run our topological sort algorithm on top of it. Then we figure out which one can be executed in parallel, which one can be executed first. And that's sort of the thing we do with Briefly. So this is actually the node object or the class hierarchy in Briefly. We have node, we have process, and then we have spatialized process like Java process, shell process, or Hadoop process. And then we have a user-defined process if you want to define your own. And then we provide a way so that you can actually do it easily. So let's look at the magic node object itself. This is basically a snippet of the node object. So what is a node? A node is something that can be executed. And also, it has the ability to be configured, like take a parameter or something. Sorry, not a parameter, but change how it works. And also, it has the ability to check if it needs to be executed. This is the idea that from Makefile. So if you check your input and output timestamp, and then you found like your output is actually newer than your input, then you don't have to execute this. So this function provides us the ability to sort of like make the pipeline resumable. If you run the pipeline and something failed, you change it, then you can continue to run. And this is actually the sort of like the pipe operator or the OR operator. So what we do is that we put this main source to yourself as the main source of the next object. So when we actually build our graph with this object, then we can chain them easily. So basically what I'm saying is that when you actually write syntax like this, we're actually not executing anything in Python, but just build a graph. So everything you see here is actually the object. So how we do that, let's continue. So the next thing is something inherited from Node, which is a process. Why we need this process is because if we want to call something, we have to send the parameters. But when you create object, they all have the similar interface. So we do need to handle all different type of parameters. So we remember all the parameter. And so later on, we can deal with it. And then also we provide a hash function so we can generate unique names for each node. And this is also important because there are a lot of duplications in the pipeline. Like for example, here we have the same input goes to the same preprocess, and result one goes to full process and bar process. So you can see the input goes to preprocess is actually the same, right? So but here we created two objects. So without the hash value, your pipeline is not efficient because you actually run the same thing twice. So that's kind of the thing we do in briefly. We use the hash value so that it's equivalent to this. Because they have the same value, so we only evaluate it once. That's the use for hash value. Okay. Now let's look at one simple Python node or Python process. If I want to write a briefly process in a way that we really want to make it look like a functional style programming. By functional style means that you just think like everything is a function. So if you have input data, you have lines, you want to read it, you want to process it, and you should just write a function instead of writing a class. But as the problem we just described, in the end, we really need to declare some class. So this is actually the dump class we declare, and then we override the execute method inside it, right? But you probably think like this is kind of similar, but that's because I ignore omit some of the dirty cleanup here, because you have to create a constructor, you have to deal with the parameter, then you have to train them all together. So this is actually more complex, but this is conceptually we want to do this. So how you can do that in a sort of like magical way, by augment a function to a class. And thanks for the dynamic nature of the Python programming language, we can actually do that with the decorator. So this is actually the wrapper we use to augment a function into a class. So here, if you define something as a simple process, and what we do is that we create a new class for you. As what you can see here, there is an inner class. And because it's inside a function, so every single time you call this wrapper, Python would create a new type for you. And of course, in the execute function, we have to chain back to the original function you created, which is this one. And then this is kind of the interesting thing is, after you create the class, you don't want the class name to be process wrapper, right? So you have to change, sort of like for Python, that you change the class name to your original function name, and then return it back, so it occupies the global dictionary. So after this wrapper, you actually have a class called dump, and which does the thing for you. So that's kind of the cool idea we do in briefly. And of course, we have several different type of wrapper for different type of process. But as you can see, we really want to focus at the conciseness and sort of like put it in the elegant way. We don't want to think about object-oriented programming. We really want to think functional. So and all this function is the thing we care about. We don't really want to deal with the boilerplate of the class creation. Okay, and similarly, we can define a Java process or Java node. But instead of handling the data inside Python itself, this is more like kind of calling out. You just subprocess module, you call out to Java and you run something, right? So what is the minimum thing you need to execute an external Java process? You need to know where you get the input file. You need to know where you put the output, right? And of course, you need to know the class name. And then you can run everything, and probably class paths as well. So in the function, what you declare is not the actual execution of the logic. It's actually just where is the Java class, or where is the jar you are going to call. So with a similar wrapper, instead of override the execute function, we actually override the configure function. So that function basically is a provider of some information, like how to execute the external Java process here. And we augment the function to a class again, and then we can use that function to get the key parameters we need to execute the Java. So with this all combined, it's actually possible to just assign it back to a variable, because everything now is an object, right? So source to some process or cat to some process, then you can assign it to a variable. So if you want to branch, you have some sort of data, and then you want to branch the pipeline, what you need to do is like just put the data and then to two process, full and bar. Then you have two targets. Then you can run your pipeline. Or if you have a merge, a process that can take parameter, like result 1 and result 2, and briefly would use the type, dynamic type, to figure out, oh, you actually have a type that is briefly process. So then it builds a dependency on top of it. So when you actually execute this one, and then you do a trace back to result 1 and result 2, and trace back to all these two pipeline. So then you actually figure out the whole graph. So you run topological sort, and then you can run things in parallel. So now let's just go back a little bit again to our demo. This is actually the installation process. We put it on GitHub as well. So if you want to try, please go ahead. But we only test it on Ubuntu Linux. So if you test on Mac OS or Windows and you figure out there's some problem, please let us know. But unfortunately, that's the only platform we tested. So let's jump back to the example. So first, you just import briefly library and like this, and then you create a pipeline. Then here are a bunch of simple process in Python. So you can print it out, you can dump it, and then this is the one that you split every single line into words. So it's really simple. And here is another one called shell process. That if you really want to run a shell and then it's an external command, you can actually do this. And the good thing about briefly is that we provide a lot of protection. For example, you can set the timeout. If this process is executed more than 10 seconds, then we'll kill that as failure. Then briefly we'll retry that. So any type of failure, exception and Hadoop cluster failure, then we will retry that. So you can make sure that your pipeline is really, really robust. You don't want some tiny thing to fail your whole pipeline after a few hours of execution. So then this is some function that we created a lot of pipeline, like get date. And we call that the briefly process. So you create five pipelines in parallel, and then you chain them together. So how does this work? let's just run it. Oh, just a little bit. So to run it, you just run it like a regular Python program. There is nothing special. It's actually meta-programming. So your Python program is still Python. So it's not some magic here. But we provide another configuration file. So a lot of things you can change. We will see that in a bit. And basically, this gives you some input, like how many threads you run, how many times you want to retry. And you can have your own definition, like input doc, where you get the input. That's something you can get. So for example, this is actually where we get the input. And let's wrap it. So for the first pipeline, what we do is that we get the input file, and then we filter it like running a grep, and then we find some pattern, and then we print it out. And for second pipeline, we want to get a list of date and then print it, like running a shell. And the third pipeline, we actually want to split every single line into words. And then we want to count the unique lines. That what we like what we did with histogram pipeline, and sort it and had 5. So it's pretty straightforward. But in the end, we want to put all the data all together and then print it out. And this is actually our final target. So we just execute it, and that's our final output. So if we run it, then we will see that this is actually the result of first pipeline, and this is the second pipeline, and this is the third pipeline. And if we actually change the configuration, for example, but we probably cannot see it like run in 3 thread instead of a single thread, then we can run it again. Since we concatenated it, so there's no difference at all. So it's pretty easy for you to just scale up. Yeah, sorry.
What's the mechanism by which data is passed from one node to the next?
So it's actually done behind the scene. So everything. It's not. So when we actually do this pipe operator, so what we do is that for every process, we create an output file for you. So we use disk as a temporary location, but this is for local process. But if it's for Hadoop process, then we use S3. And we'll talk about that later in the file abstraction layer. So we basically see the S3 and local file system as the same thing. So we can use S3 and the local file as sort of like a buffer for you in between. And this is important for debugging because some pipeline, you really want to figure out the data in the middle. And it's just a mechanism because we cannot chain, for example, local process to Hadoop process directly. You definitely need to put the file on S3 before you can run Hadoop, for example, or HDFS. Cool. Any other question? No? Okay. So now we can do something, a little bit, just kind of modify a little bit. If we do have, our own configuration, say, hey, I want to test this pipeline, but this is production pipeline. So I really don't want to run the whole thing. I really want to have my own configuration. So what you can do is basically just create your own configuration, and then you can run it again. So let's do this, for example. Let's say if I have my own input. Okay, and then let's call it test.conf. Okay, and then we can just create this file called test.the text, for example. And then let's just put some data here. So once you do that, and then you can run it again. then you see your data is already in. So imagine that you have a very complex Hadoop pipeline, and then you want to run it with different source, different smaller input data. You don't really need to change the original configuration file. So what you need to do is provide your own small modification of it, and then you can run it locally for testing or debugging purpose. So that's kind of the thing we do a lot in BloomReach, because you really don't want to run a very large cluster for debugging before you are pretty sure that everything is working correctly. Any questions? Cool. So let's move on to the next topic. So now we've already seen some toy data pipeline. So what happens next is that you get more steps, maybe 10 steps, 20 steps. You definitely cannot run everything locally. You have to just go out to run Hadoop. So you need more computing power. And by computing power means distributed computing. So to do that, first you have to abstract your file system or storage layer, because if everything is a local file, then your data pipeline is pretty much fixed to running everything locally. So in order to do that, we leverage another open source project called S4CMD. Basically, this is our previous open source project. We use that to interact with Amazon S3, so everything can be uploaded or downloaded automatically. And it's really important for us to check the timestamp. So when we compare like a local file to a remote file, and Amazon requires you to set the time and date correctly or within certain arrow. So when you access the file on S3, you can pretty sure that your clock locally is kind of synchronized to the clock on S3. And of course, in file, the timestamp for files, they're all in UTC or Unix epoch, so you can just compare them directly. So we do this type of implicit file transfer when you have a local process and a remote process, and we would upload and download the file automatically for you. This basically enables you to test Hadoop locally. Imagine that if you have a pipeline and then you have something called upload in the middle, then your pipeline is really not flexible, because when you run locally, then you have to ignore that step, right? And this is really useful for analytics. When you run analytics or something on Mapreduce, in the end, the data could be very small. You probably just want to download a few files, summary to check the end result. And this is the use case for that. And it's also possible to upload the configurations for your Hadoop process. And we will see that in a bit. So this is basically the idea. If your pipeline is some Java process trained to a Hadoop process, and it's flexible. You can run it locally or you can run it remotely with EMR. So if you really want to run on elect Mapreduce, then briefly automatically insert upload node in the middle for you implicitly, so you don't have to deal with the ugliness of upload and download, this type of thing. Cool. Mm-hmm.
You also extract HDFS.
Currently, we don't, but because we actually talk to EMR directly. The reason we are not talking directly to HDFS, which is in our plan to do, is we want to support the Hadoop 2 API directly. If you are running your own cluster, you are provisioning your own cluster, then you have a HDF entrance, then you can actually talk to your HDF cluster directly. But unfortunately, this is not the use case in BloomReach. So that's why we don't have it today, but we are planning to do that. Any other questions? No? Oh. Mm-hmm. Okay. Uh-huh. So, sorry, this is kind of the another open source project. So if you actually Google Python S4 command, you can actually see it's actually a replacement for S3 command. Because we found a lot of problem with S3 command, for example, it cannot execute in multiple thread. It has problem to upload or download files more than 5 gigabytes in the past. Newer version, probably they already solved that. And we handle, again, multiple thread, multiple connection download correctly. So basically, this is kind of the replacement for S3 command. So go to BloomReach open source on GitHub, then you can see this open source project. It actually get more traction because we actually open sourced this 2 years ago. So a lot of people do something with it, like encryption, modified to run on Windows. A lot of interesting stuff. But yeah, cool. So now let's jump to another interesting component called the property collection. The similar concept, a lot of systems has that, like Hadoop or Spark, they all have their own configuration system. Why this configuration is important is because if you have several functions, function A code, function B code, function C, or like shell script call each other, it's really kind of annoying to pass those information along with it. So for those of you who are familiar with Hadoop, then you can set the conf or configuration for that. But they're just not good enough because Python is a dynamic language. So we really want to bring out the good part of Python. So what does that mean is that we really don't want to write something like this because if you have a property K, why not just .k directly? Python allows you to do that. So you don't really need to handle the ugliness of quote and square bracket and then double quote. This, I really hate this type of typing a lot of character. And also, you can package your configuration in a sort of like serialization way. And imagine that if you want to handle your configuration in a different programming language than in Java, and you can do that easily because our format is just a name equals some JSON. And this gives you a lot of power. You can just use any language which has a JSON parser, then you can parse it directly. And you don't have to deal with escaping, for example. If you actually write your own parser, remove the double quote, then you have a lot of problem, like /n/t, then you have to handle that correctly. And JSON also provides like list or dictionary, so you can actually use it out of the box. So another important feature for briefly configuration is that it's hierarchical. By hierarchical means that we can have something dot something dot something continuously. So you can have Hadoop binary, you can have EMR dot cluster name, and then you can put all your property settings all together. So they're basically resolved recursively. And you can actually put all your important configuration into one single file, which is shared across your production pipeline or your testing pipeline. And people want to run their personal pipeline, they just inherited it and then imported them or just modify a little bit. So give us a lot of power to run the same pipeline in a different environment. Also, we get a very interesting idea from shell scripting called string interpolation. And I cannot tell you how important this is because if you have a lot of paths, input paths, output paths, you really don't want to repeat it over and over again. So a very elegant way is basically put a base path, and then you can have input, output path based on this path, and maybe some other path based on your output path, for example. And so in this case, you have the flexibility to override any of it. And you, yes?
We have a request from our video to
Oh.
not go in front of the screen because what happens is that half of you is in really bright light, half
Oh,
of
okay.
you is in really dim light.
Okay.
And so you get a sort of
Stick here.
You get sort of, yeah, if you stick there, that'd be great.
Okay, thank you.
Thank you so much. Sorry to interrupt.
That's okay.
You're awesome.
So, for example, if you want to run some pipeline locally, you want to move everything, then you just replace base path, right? And if you just want to modify one, then you can still do that. So this gives you a lot of flexibility, change the pipeline you want to run. And this actually grows really fast. For a very complex pipeline, you probably have more than 100 settings, tiny things here, a little bit there. It's just a complexity you have to deal with. And everything is actually lazily evaluated, which means that when we actually get the value, it then interpolates and gets the value from the original string and recursively doing this until it gets the value. So you don't need to worry about which one is defined first, which one is defined later. So you can basically put it in any order and then just running things correctly. So how did we do that in Python? It's basically we hack into the object model. So for those who are familiar with Python object, they provide a lot of things like underscore, get attribute, and set attribute. So these two magic methods, when you actually intercept them, is actually invoked when you have, like for example, some object .a or .b. And your get attribute will be called when you try to get the value. So when this function is called, then we intercept them and then translate and to get the value from our dictionary internally. And vice versa, when you set the value, then we have to do the right thing recursively. So that's the magic we do with Python RTTI so that you can use the symbol directly. And of course, we want to filter out the underscore thing so that we don't mess around with the original essential attribute for the Python object. And then there are a lot of default properties provided by Briefly. So it's a good reference to just take a quick look and to see what's provided. It's also a very good reference if you want to see what you can change or what you can do with it. It's in default.py. So this property is loaded by default for all the pipelines. And you can see you can change build directory. You can set how many time you want to retry for failure, retry delay, for example, and how many thread. This is important for multi-thread execution, debug mode, and for shell execution, how many shell you can run in parallel. So these tiny things like you can configure. And Java, how many external Java processes you want to limit. And for Hadoop, you can set the runner. You want to run it locally, you want to run on EMR, and where is the binary if you run it locally. And this bunch of stuff is for Amazon EMR cluster. So you basically just set it, or you can use the default value. You don't have to change anything. And if you use Kubo, which is another provider for Hadoop, then you just set the Hadoop runner equals to Kubo. And you don't even need to change your pipeline, and then just run directly on Kubo. So that's kind of the goal we're trying to do is separate your pipeline logic with this little tiny dirty operational logic, which you need to deal with. Cool. So that's the property part. We provide you a property collection. You can modify it. You can serialize it. And now we have the ability to sort of like go into the Mapreduce driver, which is kind of the biggest benefit of Briefly. We spend a lot of time to play with Amazon EMR to give you the most of it. So what are the issues we are facing with Hadoop? The biggest nightmare is probably not some bug. It's actually the job that's running forever. So embarrassingly, in BloomReach, you can probably see like some percentage like cluster just stuck. So this is horrible. Imagine that in Java you might have like memory leak or resource leak, not memory leak. And but we are talking about cluster leak. So you can leak cluster because if you don't handle it correctly, then no one actually destroy your cluster. Then your cluster is running forever. And basically they are costing you money, and then no one noticed that. And in the end of month, gosh, it's a bill. So it's just bad. And again, it's difficult to test on those environments. So we really need to test with different type of Hadoop provider on Kubo, on EMR. So how do you define a Hadoop process in briefly? Very similar to Java process. So the minimum thing we need, sorry, I cannot go there, is a main class. So for those who are not familiar with the raw Hadoop, it's basically, imagine that it's like a Java. So you have a jar file, you send to Hadoop cluster, and they will run your class. So it's exactly similar or exactly the same to a Java process. And you have to set the input and output, either on S3 or locally. So then you can run it. And if you change a different configuration on local or remote, then you just change the configuration. So nothing changed in your code logic, when you want to run on different environment. And default values are all in default.py. The interesting thing happened here is that we provide a resource management. Most of the pipeline management or job control flow system allows you to create a single cluster. But here we're dealing with multiple clusters. If you have 100 machines, you can actually create one cluster with 100 machines, or you can subdivide them into 10 clusters with 10 machines, and then you have the flexibility. If some cluster has some problem, then you switch your job to other cluster. So that's actually the thing we want to do to get the robustness out of the box. Sorry? Yes, sir. It's actually, the question is that, is this based on top of a Yarn, right, which is a Hadoop resource scheduler? The answer is not. It's actually implemented natively in briefly because we actually control multiple clusters. So imagine Hadoop 2.0, they're basically just think about this management of a single cluster. But on Amazon Electric Mapreduce, what happens if you only have one cluster and it gets killed? Then there is no way you can handle that in Yarn directly, or you have to hack it and then to handle multiple clusters. So briefly, it's actually a layer on top of them to handle multiple clusters. Does that make sense to you? So we're trying to sort of like go out of it because not everybody use Hadoop 2.0. But eventually we will support that. And maybe just every single job, all the jobs just sent into one cluster if that's what you want. Then we can have another resource management. Basically just does nothing, but send all the job to one single cluster. But here we are talking about multiple clusters. Currently, we don't. Again, it's because in BloomReach, all our Mapreduce or Hadoop job is in raw Java. So we just use Java directly, and we send a jar to EMR cluster. But we are trying to wrap, for example, Apache Spark and other type of jobs as well. But we haven't tried Pig or any type of other type of job. Cool. Now I want to show you a very sort of like example. If we do have this type of flow, and we want to run in multiple threads, more than 3 threads, and we have allowance we can create a 2 EMR cluster. So what happens in briefly resource management? So imagine this S is some local job you have to run. It might take an hour, it might take like 5 minutes. And all those H1 to H5, they are Hadoop jobs. So first, you have to execute your local job. Right? There is no way that you can avoid it because these are the dependency for this 3 jobs. So after this one finished, simultaneously, this 3 things can be started right away because you have more than 1 thread. Right? So let's break it into this separately. But remember, those 3 things actually happened at the same moment. So the job 1, the H1, Hadoop 1, want to execute something on EMR. So it talks to the cluster manager, and we found like, oh, there is actually an empty slot for that. So it would occupy that slot, say, oh, I want to run the H1. And this slot will figure out that, oh, there is no current cluster associated with that. So it would talk to Amazon EMR through Boto library and create this cluster for you. So you don't have to handle this Boto API, this ugly, and it just gets created. So now this H1 would start to execute on EMR cluster. And similarly for H2, it found this empty slot. And then, there is no EMR associated with this slot, so it will create another one. So now interesting thing happened to H3 because there is no available slots. So this thread would be blocked. And it just basically wait until any slot is available. So this allows you to control like how many clusters you want to create on EMR. So you see like this cluster, they basically can multiplex and run multiple jobs. And it's really efficient because we want to share this same cluster for all your pipeline. We don't want them to just run a single job. And let's imagine that H2 just completed. So once this job completed, this slot won't kill this cluster right away. We wait for like 10 minutes because we know there might be a job want to get this cluster and execute something right away, like H3. So in this case, H3 the thread would be unblocked and then get the slot and execute right away. And then H1 finished. But at this point, we cannot kill EMR cluster 1 again. We have to wait for a while, 10 minutes, and then this cluster gets killed. So this basically reduces the cost because we only have one job we want to execute at this moment. And H3 continue to run, maybe an hour or whatever, and then H4 take over. So in this case, when H4 try to pick the empty slot, it will try to pick the one with currently with the running cluster. We use a priority queue here, so we won't get this empty slot by default. Because if H4 gets this empty slot, then you need to create another cluster, which is not efficient. And then similar for H5. And after everything is done, then all the clusters are destroyed. One important thing in briefly is that we handle all the type of failures and exception. For example, Control-C interrupted correctly. So when you actually click Control-C with your briefly process, we release all the resources. So we have to, destroy all the cluster for you. A lot of pipeline controller doesn't handle this correctly, so it will leak a cluster in some situation. So the next cool thing is that we use a spot instance because we want to beat some prices and then we want to sort of like minimize the cost. So we have a bidding strategy you can set in briefly. So originally you want to bid a very low price, and then if it gets killed, and then you want to bid a higher price. And this can be configured in properties as well. So you can have your own strategy, how you want to bid. If you set the price to 0, then we will use the on-demand price, on-demand cluster, which is really expensive, but it won't get killed. So this is how it works. So imagine that originally we bid the 2 clusters with just 20 cents, and they're just running. And suddenly, for some reason, one cluster gets killed because the spot instance price goes up. But the interesting thing on Amazon is that not all your clusters will get killed at the same time. Maybe someone just outbid you for a certain capacity. So it's not necessary that the same bidding, the cluster with same bidding price would get killed simultaneously. So let's say this cluster gets killed. So the slot would actually send the exception back to the original thread. So now this thread gets a failure, and it will retry again based on our settings, how many times you want to retry. So, but remember, H3 is also blocking. So in Python, the resource manager basically is actually a queue-like system. So H3 would actually get this slot first. And it will figure out, oh, there's an empty slot, so it will continue to execute, but H1 will be blocked. So this is actually good for us, because for some failed job you want to try later, you don't want to try right away, maybe let someone else to execute first. That's kind of the cool thing. But here in this case, because the slot actually remember its previous bidding price, so it will actually try to bid with a higher price. So it will try to create another cluster, which is cluster 1 prime, with a higher bidding price. So briefly also handle this for you. And this is all running under the hood, and you don't have to worry about that once you set this correctly. So now we have everything. Yes?
So you have like a small configuration that specifies some elaborate policies to follow?
Yes. So let's show you in this demo. Now we want to run some Hadoop pipeline. But again, we just want to run it locally because I don't want to use the company account to run a cluster. It probably takes 40 minutes to provision, so I cannot show you in time. So for a Hadoop pipeline, let's see. You have a bunch of configuration, like Hadoop, binary, where you want to run the jar, etc. And as the question is where you can set the policy for EMR. Again, it's in default.py if you want to take a look. So the bidding price policy is here. So it's basically just a list. So if you want to bid any type of instance, say M1 extra large, and you can set your pricing policy here. 0.8 means the basically 0.8 times the original on-demand price is your bidding price. So we are saying that the first time we're trying to bid with lower price, and the second time we're trying to bid 1.5 times the on-demand price. And the third time, if we fail twice, then we use on-demand cluster. We don't want to bid anymore. So that's our policy. And you can configure this policy in your configuration file. For your production pipeline, you want to use this policy. For your testing or debugging pipeline, you probably just want to use on-demand price directly because you don't want to waste time if your debugging clusters fail over and over again. It's just basically wasting time for your debugging process. Cool. So now let's go back to our Hadoop pipeline. It's actually simpler. So again, we have few simple process. You can have Python process if you want to handle any type of data, and this one just again gets a word out and then emit the count, and only allow the English words and no other spatial character. So here is the Hadoop process we want to define. This is actually the example in Hadoop distribution. So this allows you to just download Hadoop and run it directly. This is just a demo. But if you have your own Hadoop jobs, just replace this with your own configuration, and then you can run it. And so the pipeline is really simple. You get from the same file, you run this word count, which is Hadoop job, and then you run some local Python process. And then again, you sort, and then you head the first 10 line, and then you're done. So let's try to run this. Oh, sorry. So it probably take 5 seconds. It launching Hadoop, and then it sorting stuff. And then you can see the result here already. So if you actually go to the build directory, as we talked earlier, every single process has a separate log file. So if you look at this word count, log, you can actually see the output from the Hadoop process. So this is actually the full log of Hadoop process you just executed. Cool. Now the last part, just 2 slides, is the log structure. Once we get to the complex pipeline, there are hundreds of steps. It's just really painful to run it every day in debugging. So we really need to put all the log file into one location so you can easily find it. And this basically is based on our hash value for each process. And you can find that easily. And you can also change build directory if you want. The best practice for briefly pipeline is actually build small pipeline to drive large pipeline. The idea is really similar like our engine. You have a motor to drive something which is bigger. Imagine that if your pipeline need to get a lot of configuration, maybe from your configuration management system or some SQL file, before you can run the full pipeline. It's really difficult to mix everything together. You probably want to run a small pipeline to get all the configuration and put it into one file, serialize it, so you can figure out what's going to be executed on a larger pipeline. So we actually did this practice a lot in BloomReach to get all the configuration first and serialize it to a local file. And then we send this file and then use this configuration as planned to run your Mapreduce pipeline, maybe with 100 customers all together. So that's kind of the best practice of that. Cool. I think that concludes our talk. Again, this is not a project done by one person. I really want to use this chance to say thank you to a lot of contributors. And again, this is the first time, so I don't know if this is too much or is it too high level, or because we do have a lot of operational experience with electric Mapreduce, so we try to overcome those operational issues. But on the other hand, we also want to bring the goodness of functional programming into our pipeline construction. So that's kind of the end goal, because I really like functional programming on top of object-oriented programming. Cool. Yes.
Failures. I mean, how robust is this on programmer errors, system errors, unexpected? How long have you been using it operationally? How challenging?
This was actually done a year ago. So after a year, then last month we open source it. So for my pipeline, it's already running for a year, really without any major instance. Imagine that in the past, every single night or like once or twice a week, you get a pager because some Mapreduce fail, and there are just a lot of operational issues. Either a spot instance, or a bootstrap action fail, and in the end, people just cannot handle the complexity. Either your pipeline is too complex or there are too many operational issues. So we really want to separate this from the business logic and the operational issues, so people can actually focus on the data or the logic they are processing. So we're running this for 1 year. We handle more than 100 clusters every day. I think we're really happy with it. So that's the reason we open source it.
How many times do you have failures? How many the pager a day before? What's it now?
The failure still happened, but because it retried, again, it a bit higher, so you don't actually see it. I rarely see it, maybe once, every 2 or 3 months, but it's rare, because we can actually run it very efficient. Yeah, and it's failed, no problem, just retry, right? It doesn't need to fail the whole pipeline just because of one tiny failure. Yes?
How do you handle the scheduling?
You mean the Hadoop particularly?
No, not necessarily, but how do you schedule, for example, weekly jobs?
So again, this goes back to how we actually build the graph. So if we have this type of graph, the first thing we do is run a topological sort. So then we know which one can be executed first. And after that, because we have multiple threads, so you actually need to figure out, for example, which one doesn't have the in link. For example, if you actually completed S, right? We actually remove the S node, and then you know from S node there is actually called bridge node to other nodes. This is actually a graph algorithm. So from here, you can actually figure out this 3 nodes can be executed simultaneously. Then you actually have a thread pool. Then you can assign a thread pool to each one. And this is actually set in your configuration, like how many threads you want to execute totally for your briefly pipeline. Yes? Uh-huh. Yeah. Yes. So that's why in briefly configuration, you see that we always have timeout. We actually have a step timeout or total cluster timeout. So you can set this step timeout. For example, each job you can run like 12-hour maximum. If you know that your job should not run over 2 hours, you can set it for 4 hours. Then you can sleep nicely every night. Because if something runs more than 4 hours, you definitely know there is something wrong with the cluster. Either the provisioning is not correct, or some instance gets killed. If you want a 10 machine cluster, maybe you only get 1. So that's the reason why it's running really slow, or some other issue. And similar for all the local processes, you definitely need to set a timeout for each process so that you can kill them and retry. So that's kind of the key for briefly that we can run things in a robust way. Yes.
I'm not super familiar with Amazon architecture, but is it common practice for each job spin up a
It's definitely not. So that's the benefit for briefly is that you want to create a cluster and share it as much as possible. If you just create a cluster for each job, then it's really not efficient. So the idea for briefly is that you can create a fixed number of clusters, say 2, 5, or 10, and run hundreds of jobs across them. So you get the maximum efficiency out of it. They are not, but you can configure it. Every single cluster is independent. So on Amazon, every cluster has its own HDFS on top of it. So if you really want to share data, you have to write your Hadoop process pointing to the same HDFS cluster. So this is actually a different concept. In Kubo, you can actually do that because they keep a small HDFS cluster for you. But this is kind of outside the configuration or the premise of briefly pipeline. But you can do that, but not in briefly today. Yes, but in BloomReach, remember, there is actually another scenario in Amazon is that you can actually put your data on S3. S3 is actually always available. So if you actually have a lot of data and you want to run on multiple clusters, you can still do that if all your data is on S3. Does that make sense? Yeah. Okay. Yes. And exactly. And if you want to copy from S3 to HDFS, you can also do that in a way that you have to do it yourself. Any other questions? Cool. Thank you. I think we end a little bit earlier, but really appreciate that. So if you have any comments, you use it and you found any problem, please email me. And or post it on the GitHub forum, and I would be happy to answer all the questions you have if you have later. Thank you.